Hi, wonderful students. I'm going to talk about the square root property and completing the square. And these two items have a relationship. So the kind of the easier problems are going to use the square root property. This is an example. I have x squared equals 25. So by guess and check, you see that both 5 and negative 5 work. But the square root property says that you can take the square root of both sides of a problem, of an equation, and when you do that, the square and square root are going to cancel, and on the right-hand side, what I do is I pick up both the positive and the negative, and that doesn't happen unless it's an even root. So it's actually called the even root property, but we're just going to simplify it down to the square root. We're going to do this whenever there's squares. Okay, one thing to note is if you have something out here, like say you put a 9 in front of the x squared, okay, divide the 9 to the other side first, and then because I'm low on the board, I'm just going to erase my 9 instead of rewriting it. Well, that's a bit of a mess, but that's all right. You guys can handle it. Now, what I have is something that looks like the previous problem where I can now take the square root, and those square and square root cancel, and I have a solution of x equals 5 over 3 or negative 5 over 3. So this is called isolating. You're isolating the radical first. You get it by itself. Okay, so that's the square root property. If I have something that looks like this, there you go, that's complicated. You can't just run around taking the square root of things. You have to isolate the radical first. So if I add 1 to both sides, now divide the 2. Okay, this is all part of that first step. You have to isolate the radical, or I'm sorry, in this case it's a square, so or square. We're going to do the same thing with a radical, so I'm sorry I used the wrong vocabulary there, but we got this. Now you can take the square root of both sides. This is the square root property, and you pick up both the positive and the negative. I'm going to use slightly different notation. Instead of writing it with a comma as I did there, I'm going to use the plus and the minus. The square root of 5 doesn't simplify, so you just leave it as the square root of 5. There. That's nice. Okay, on the next problem, it doesn't have a square in it yet. And so what you want to do is you're going to do legal algebra. You're going to add and subtract things to both sides. As long as you add or subtract to both sides, you're totally legal in an effort to create a square, a perfect square. And I always think of that movie Ice Age, where the little swirly guy, I can't remember what he is, and he goes, oh, she completes you. And she's talking about how Manny and the other, anyway, you know what I'm talking about. So we're going to complete the square. We're going to create a square, something that has x, blah, 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 something squared, this right here. So clever adding and subtracting. Okay, it's an equation. And I don't have something just squared because I've got this other stuff running around. And this doesn't factor nicely. But if I move this c to the other side so that I've got something kind of nice, I have x squared plus x. Now remember, I'm going to add something to both sides. So I'm going to leave myself some space there. Now, what you're going to add is 1/2 of the coefficient on the x term. So 1/2 of 1, remember that's 1. And you're going to square that. That's what gets added to both sides. So x squared plus, let's see, 1/2 squared is a 4th. And 4 plus 1/4. Now, what's hard to see, and I'll see it better on the next one, is that 1/2 and that 1/2, when they multiply together, would make that 1/4. If you outer and inner, you see that would give you that 1. So 1/2 and 1/2, 1. So what have I just created here? I have just created a perfect square. So this is 17/4. Don't worry about it. I did fraction work fast. You guys can grab a calculator. What I have then is a nice, perfect square, 17/4. And now I'm back to this problem, where you take the square root of both sides. You have x plus 1/2 is equal to plus or minus the square root of 17/2. You might as well go ahead and do the square root of 4 because it's always going to be even. Now, because I'm low on the board, what I'm going to do is I'm just going to subtract the 1/2 over here and erase it. Okay, that's a little bit cheatier because you're not going to be able to do that on your work, but that's going to make it so that I've got two solutions. Excellent. Here's our next problem. In this problem, I've got a similar issue to here, right? I don't have a perfect square, but I can create one. And to do that, I'm going to get the x squared plus 10x by itself. Now don't forget, leave a little space because you're going to add something. And what you add, remember, it's half of the coefficient here, coefficient on b, because if you add half of it and then square it, it will all work out because the 1/2 times the 1/2 will give you back to the 1/4, right? So I'm going to have something that when I multiply out comes back to whatever comes here. So anyway, that's a lot of rambling. Let's do half of 10, that's 5, and then let's square it and put it in both places. Now, when I do this, I know this is going to be perfect. It will always create a perfect square. And what is the perfect square? Well, it's 1/2 of this and then squared. Now you can see 25 is 5 times 5. And on the right-hand side, I've got 23. Oh, this is good. All you got to do is take the square root of both sides. And I have x plus 5 equals plus or minus the square root of 23. Move that 5 over, and you're done. Okay, completing a square is a really nice method. It is really, really nice. The last problem I want to do is if the coefficient on the first term isn't 1, you're going to need to divide that out. But then I instantly want to divide by 2 because everything's even. So let's divide, instead of by 2, let's divide by 4. Because in order to complete the square, I need to have a is 1. So this is one more additional step beyond these two problems. And when you do this, it's always going to divide out to 0 as long as you solve for 0 on this side. So it doesn't really create more work there. It does sometimes create a fraction here, but that's not terrible. We can handle that. So this is a 3x plus 1/2 equals 0. Now subtract the 1/2 over. And see, I've got to have a fraction here. It's going to be a little bit ugly, but we can do it. So 1/2 of this, so just write it as a fraction like that. 1/2 of 3 squared. Now, what I really care about is the 3/2, right? So I'm just going to leave it as 3/2 here. Now over here, what I really care about is the 9/4. So I'm going to erase this just so it's out of my way. And I'm going to go ahead and write this side as a perfect square. I can check by multiplying 3/2 times 3/2, and I would get 9/2 squared, and then 3/2 on the outer, 3/2 on the inner, and you would get 3, right? Because half 3 and half 3 is then 3. All right, this, let's multiply this by 1 in the form of 2 over 2. This gives me -2 plus 9, which is 7/4. Now I'm all set up. Take the square root, plus or minus, move the 3/2 over, and we're done. Okay, let me finish that. We have x plus 3 over 2 equals plus or minus the square root of 7. Go right ahead and do that. Square root of 4 is 2. Move the -3/2 over, plus or minus square root of 7 over 2. Very nice. And that's completing the square. Good job!